This LOS is define spot rates and calculate the price of a bond using spot rates. Bond prices and the time value of money. So now we're looking at pricing bonds with spot rates. When a fixed rate bond is priced using the market discount rate, the same discount rate is used for each cash flow. A more fundamental approach to calculate the price of a bond is to use a sequence of market discount rates that correspond to the cash flow dates. These market discount rates are called spot rates. Spot rates are yield to maturity on zero coupon bonds maturing at the date of each cash flow. Sometimes these are called zero rates. Bond price or value determined using the spot rates is sometimes referred to as the bond's no arbitrage value. If a bond's price differs from its no arbitrage value, an arbitrage opportunity exists in the absence of transaction costs. So here's an example. Suppose that a 1-year spot rate is 2%, the 2-year spot rate is 3%, and the 3-year spot rate is 4%. Then the price of a 3-year bond that makes a 5% annual coupon payment is 102.96. So you have to use algebra, and I said here the exam would never give you more than 3 to 5 years. So you can't use the time value of money because you're not putting in an I and Y, okay? You have to do the present value of each individual cash flow. So you can see that I'm doing the present value of the first coupon, the second coupon, and the third coupon combined with the $100 par value, and I'm discounting by 2%, 3%, and 4% for the 1-year, 2-year, and 3-year, and therefore you can see that the price of the bond is 102.96. Okay, recall this learning outcome statement is define spot rates and calculate the price of a bond using spot rates. So I've shown this before and I'm going to do it again. I'm just showing the importance of the glossary again. When it says define, that's definition. The definition for spot rates is just in the glossary. I recommend that you print out the glossary, and it's a very valuable document with regards to the definition. So spot rates is a sequence of market discount rates that correspond to the cash flow dates yield to maturity on zero coupon bonds maturing at the date of each cash flow. And the spot curve is a sequence of yield to maturity on zero coupon bonds, sometimes called zero or strip curve because coupon payments are stripped off the bonds. Okay? Continuing with bond prices and the time value of money. Bond prices change as time passes, even if the market discount rate remains the same. As time passes, the bondholder comes closer to receiving the par value at maturity. The constant yield price trajectory illustrates the change in the price of a fixed income bond over time. This trajectory shows the pull to par effect on the price of a bond trading at a premium or at a discount to the par value. If the issuer does not default, the price of a bond approaches par value as its time to maturity approaches zero. Again, we saw this before when we looked at the accounting for bonds when they were issued at a discount or a premium, because we need to amortize that discount or premium over time. Okay, for the next two slides, I'm just going to bring back that example that we did back in the accounting because it's a nice one. We looked at the example of the bond that was issued at a premium and it got pulled down to par, okay? So bond prices change as time passes even if the market discount rate remains the same. Again, we saw that before in the accounting. I'm going to bring those two slides in again. If you're up to speed on that, you can skip ahead. So now we're going to look at the accounting for a bond that's issued at a premium. The bond has a face value of £1 million. The coupon rate is 5%, so the annual coupon payment is $50,000. It's for 5 years and it's annual pay. But in this case, the market rate has gone down to 4%. So when we bring up the calculator again, let's do our calculation. So it's 5N. The interest rate, though, has gone down to 4%, so it's 4IY. Our payment is still the $50,000. And our future value, face value, is the £1 million, okay? So when we calculate our price of our bond, the cash that we received, we can see that it's $1,044,518.22, okay? So in that case, that's the cash that we're going to receive, which we know is more than the face value or the future value. So in this case, we're receiving more cash. You can see that we're going to be pulled down to par over as we amortize the bond. So this is a similar table. Let's go through it. I'm going to issue the bond. I'm going to debit cash, $1,044,518, and I'm crediting the bond payable. You can see in this case, my debit is higher than my credit, so I'm going to credit the bond premium. It's going to be a credit balance of $44,518.22. And again, as I make my coupon payments every year, that's going to be a credit. Credit my coupon payment, £50,000. But what about my interest expense? Remember that we said our interest expense is based on the carrying value times the market interest rate. So if I bring up my calculator here and I make that a positive and I multiply that by 4%, we can see that the interest expense in the first year is $41,780.72. And I've rounded that 728. So you can see here, that's my interest expense, $41,780.73. That's a debit. But you can see my credit is $50,000 on the £50,000 because that's a credit to cash. So my debits are less than my credits. So I'm going to debit the discount bond, the premium bond payable account 8129.27. So that's a very similar exercise. And you can see I started with a credit balance, but now I'm debiting the account. So that balance is going down. And so my face value is going down, okay? And it's being pulled towards the par. Okay, this is the same data from the previous slide. We're just looking at this bond that we've issued at a premium. On the top here, I've got my journal entries. On the bottom, I've got my T accounts, my general ledger accounts, and on the right-hand side, my chart, and I'm showing the ending carrying value as it's being pulled down to par. So let's just go through it very quickly. I issued it at a premium, so I received £1,044,518.22. That's a debit to cash. I'm going to credit my bond payable, $1 million. You can see my debits are greater than my credits. So as I said, I'm going to credit the account premium bond payable. Then my interest expense, recall, is based on my carrying value times the market rate. And we did that calculation. The interest expense was $41,780.73. I'm crediting the cash. The coupon payment never changes. Credit cash $50,000, credit cash $50,000, credit cash $50,000 5 times. So you can see my interest expense is lower than my coupon payment, so it must be a debit to that account. So you can see that down here in the T accounts as well. I'm going to debit my initial cash, credit my bond payable $1 million, but my debits is greater than my credits, so it has to be a credit to the premium on the bond payable. And then as I scroll through, I'm going to credit my cash, $50,000. I'm going to debit my interest expense. It's a debit to the premium, so you can see this balance is going down, and so the carrying value of our bond is starting at $1,044,000, and it's being pulled down to par. So this is very important to understand the accounting for a bond issuance. Par is very easy. Discount and premiums, we have to look at our debit on cash, our credit, our bond payable is always the face value, but then we either have a debit if it's at a discount or a credit if it's at a premium, and then our interest expense is not matching our coupon payments, so we have this amortization on the discount or premium. And if it's at a discount, we're being pulled up to par. If it's at a premium, we're being pulled down to par. And as I mentioned, with regards to the cash flow from operations, these amortizations on premiums and discounts are non-cash items, so they have to be added back or subtracted, okay? So let's do a practice question to check our understanding. An investor purchases the bonds of JLD Corp, which pay an annual coupon of 10% and mature in 10 years, at an annual yield to maturity of 12%. The bonds will most likely be selling at A, par, B, a discount, or C, a premium. Now this question should be fairly easy, but sometimes it's nice to do an easy one, correct? So B is correct because the coupon rate on the bonds is lower than the yield to maturity. So sometimes I'm just going to do like this. I'm going to do 10%, that's my coupon, and I'm going to do 12%, that's my yield to maturity, so that I know that the bond must be trading at a discount. I need to lower my price to increase my yield, okay? The coupon is at 10%. Anyhow, the coupon is on the bonds is lower than the yield to maturity, implying that the bond should be selling at a price lower than their par value, that is at a discount. So that should be an easy question. And that's the last slide for this LOS. Thank you.